Here we've got a classic interview question talking about density. Now, we're told a steel submarine filled with air has neutral buoyancy in water. Neutral buoyancy just means that it floats without and if we left it for an extended period of time, it would stay at that altitude and it wouldn't try and float upwards. So this basically means that the net density of the things floating, the submarine, is equal to the density of the water, which is the liquid it's floating in. So we're asked to determine the ratio of the mass of the steel to air for the submarine to remain at neutral buoyancy, if we're assuming that the submarine is made only of air and steel. Now, for neutral buoyancy, the density of the water has to equal the density of the submarine. But we have to be slightly careful here, because since density is the mass per unit volume, the average density does not equal, it's not an arithmetic mean, if that makes sense. You have to consider the masses and the volume separately, because it's made of an inverse, and when you add, so if you add 1 over A plus 1 over B, that is not the same as 1 over AB, is it? So the way we can get around this is by considering a simpler example first. Let's consider two objects, A and B. Let's go A and B. We have mass, volume, and then the density. Now let's consider this. The density A is going to be m over v. Density B is 2m over half v, which is 4 m over v. And so if we add the total, it'll be 3m, and this will be 3 over 2 v. So it turns out that the overall density, which I'm calling density total, is going to be, I'll write it down, turns out that the overall density is going to be 3m over 3 over 2 v. Which gives 2m over v. So as you can see, you could not have got this from adding m over v and 4m over v. Now, with this in mind, we can start by saying that if we call the mass of air m air, and the mass of steel m steel, we need to know that the total, so the net density of the submarine has to equal the net density of the water. So the net density is given by this, which equals density water. Now, if we're saying, because they're masses, they're both constants, and we can relate, we need to find the ratio between them. So an easy way to do this is to say, let m air be K times m steel. And so steel, this K is the ratio of their masses. Now, this means that if we plug this in, we'd see that K plus 1 times m steel all over K m steel over density of air plus m steel, sorry, it's all in terms of steel, over the density of steel, because now I've used the densities and I've eliminated the volume variables, equals the density of water. Now, if you're confused where this has come from, it's just using the fact that since density equals mass over volume, this implies that the volume is the mass over the density. Hence why here there's mass over density, and here there's another mass over density. So with this equation that we've got up here, what we can then do is plug in some values. And since now we're only using one variable for mass, I'm just going to abbreviate M steel as M. It's a little bit lazy, but it perfectly is functionable. Now, what we'll actually see is that if we cancel this out a bit, we know that the density of air is 1 meter cubed, 1 kilogram per meter cubed. Density of water is 1,000, and the density of steel is 10,000 kilograms per meter cubed. So we get at this equals 1,000. And now instantly, whilst it's still a messy fraction, we can see that the masses cancel. So we're left with an equation in terms of we've got one equation with one unknown, so we know that there's definitely valid solutions, or there is a valid solution that exists. Now, if we rearrange this, we get that k plus 1 equals 1,000 k plus 1 over 10, I believe. So then times it all by 10. 10k plus 10 equals 10,000 k plus 1. So then we get 9990k equals 9. And so k has to be 1 over 1110. So what this tells us, this is actually very a bit anti-intuitive, that for it to float, we need there to be a thousand times more steel than there is air. But why? You see, it's to do with density. If we then considered the volumes, it would be opposite. You need a lot more air, but because air is a lot less dense, its mass is less. So considering mass might be slightly misleading. But I hope that's been interesting. Thank you for watching.